Fine. What is nucleophilic substitution reaction or nucleophiles and electrophile?
So nucleus loving group of the
Nucleus
nucleophiles.
loving groups or nucleophiles. Then electrophiles,
The electron loving group.
electron loving group. Fine. Okay, so nucleus loving groups, we will call it as a nucleophile. Generally, the represented by this particular form. It is a charged one. Nucleophile has a negative charge over the
Negative charge.
over the species. And you may also find some of the nucleophiles which has a neutral charge. So let's deals with this nucleophile Nu minus. Nu minus stands for the nucleophile, and generally in the nucleophilic substitution reaction we will call this like Rx. R can be of any like alkyl or aryl substituents. Alkyl is generally substance Rx, wherein we will call this as a substrate. And okay, so we will call this as a substrate and a nucleophile. And during the nucleophilic substitution reaction, the substitution, what substitution stands for?
Replacement. Sir.
Replacement, yes, of course. Replacement of one of the existing group or functionality with the other functional groups or species. So in this case, the nucleophile is the one, it prefers to attack over the carbon which is carrying the leaving group. Generally, the leaving group will be X. So X is any halide systems. This X will be the leaving group, and nucleophile prefers to attack over the carbon which is carrying the leaving group during the nucleophilic substitution reaction. Then during the nucleophile, if it is prefers to attack over the carbon which is carrying the leaving group, then the Nu will try to replace this X and forms a new carbon and Nu bond. And meanwhile, there is a breakage of bond between the carbon and X. So X will leaves out as a X minus during the nucleophilic substitution reaction. This is the general representation of nucleophilic substitution. Here we are not covering SN1, SN2 or at the moment. So SN1 is a nucleophilic substitution unimolecular, and SN2 stands for the nucleophilic substitution bimolecular. So if any of the nucleophilic substitution reaction, if you are discussing, general way of discussing is you need to have an alkyl halide and nucleophile as a species. Then the nucleophilic substitution occurs over the carbon which is carrying the leaving group, and it attacks over the carbon and the leaving groups leaves out, and you will get a carbon and Nu bond formation. So this is the new bond formed between the carbon and the Nu, and the CX bond has been broken out, and you got the X minus. So this will act as a leaving group. So certain examples corresponds to the nucleophilic substitution reaction. So as I said, this alkyl halide, alkyl group can be of this methyl. If you are introducing methyl here and X stands for the Cl halide, then this is actually, what is the name of this compound?
Chloromethyl.
Methyl chloride.
Methylene chloride, right? So methylene chloride. And nucleophiles in this reaction,
Hydroxyl group.
hydroxyl, okay, OH minus, so hydroxide ion, right? So alkyl group and nucleophile. During this, nucleophile prefers to attack over the carbon which is carrying the leaving group. The leaving group in this case is the Cl.
Chlorine.
So if it is OH minus prefers to attack over the carbon, and then the bond breakage between the C and Cl occurs, and Cl leaves out as a Cl minus. So this will be the leaving group, and the new bond establishment will occur between the carbon and the oxygen. And simultaneously, sometimes the C-Cl bond breakage do happen, results in the the leaving group leaves out as a Cl minus, and a new bond formation exists between the carbon and oxygen. The resultant product during the reaction of methyl chloride and the OH minus gives to the product. Which product?
Methanol.
Methyl alcohol.
Yeah, methyl alcohol or methanol. So that means conversion of alkyl halides. This is alkyl
To
halides
alcohol.
to alcohol with the help of nucleophile. The nucleophile used in this reaction is OH minus. So one can convert alkyl halides into the various type of product through nucleophilic substitution reaction. In this case, alkyl halide has been converted to the methanol, that is methyl chloride converted to the methanol with the help of nucleophile of hydroxide ion. And after the reaction, you will be having a leaving group, that is Cl minus, in the reaction mixture. Then let's move on to the second example. What is the name of this compound?
Propyl iodide.
Propyl iodide. So whether it is iodide, so whether it is 1-propyl iodide, N-propyl iodide, or isopropyl iodide.
1-propyl iodide.
So this is 1-propyl iodide or N-propyl iodide, right? Both are same.
Yes.
Are they different? N-propyl and 1-propyl.
No, sir.
Both are same,
Yes, sir.
right?
N,
So
Yes,
N,
sir. It's the same.
yeah.
N is the position, sir.
N, when N you are using, it's a linear, right? Okay. So N and 1-propyl iodide, and the nucleophile you are using is
Thiol group.
thiol, SH
Thiol
minus.
group.
Thiol. Okay. So during this, what will happen? So instead of using nucleophile of OH minus, here you are using a nucleophile of SH minus. So SH minus will act as a nucleophile, and the substrate you're using for this reaction is propyl iodide. And here the reaction, the nucleophile prefers to attack over the carbon which is carrying the iodo group, not the carbon carrying the 2 hydrogen atom and the CC bond, or it cannot attack over the terminal carbon. It prefers to attack over the carbon which is carrying the iodo group. And during this reaction, SH minus is a nucleophile, prefers to attack over the carbon which is carrying the iodo group, and the bond breakage will occur between the carbon and iodo, whether it is a homolytic fission or heterolytic fission. The bond breakage between the carbon and iodine.
Homolytic.
Homolytic?
Heterolytic cleavage. Heterolytic cleavage.
It is heterolytic, not the homolytic. If it is homolytic, then you won't get the I minus. Instead, you will get I dot. That is free radical formation. So if you wants to get the I minus or like a leaving group with a negative charge, then the cleavage between the carbon and the leaving group should happen in a heterolytic fashion. That is, generally the bond cleavage occurs very much close to the carbon, not close to the Cl. If it is the bond breakage taken place close to the carbon, then only the leaving group prefers to have a negative charge. I think after 9 minutes, you may need to rejoin by clicking the same link. Okay?
Yes, sir.
Okay. Just get used to it. So after every 40 minutes, so you need to rejoin.
Okay, sir.
Fine. So in this case, the SH minus nucleophile prefers to attack over the carbon which is carrying the leaving group of iodine. Then the nucleophile prefers to attack over the carbon and the leaving groups leaves out. The product formed will be CH3, CH2, CH2, SH, that is
Thiopropane. Propane.
propane,
Yes, sir.
thiopropane. Then the leaving
Iodine.
group, iodine. So any other names for this? Propane thiol.
Yes,
Propane
sir.
thiol.
Yes.
Yes, sir.
Yes, sir. Yes.
Okay.
Yes, sir.
So fine. Next, the third example is what is the difference between these two, first and second example? Any difference you have noticed between the first and second? So in the first case, we have used the alkyl chloride as a substrate and nucleophile of OH minus. In the second case, we have used the alkyl halide series only, but instead of chloro substituent, we have used the iodo substituent, and we have changed the, instead of using the nucleophile of OH minus, we have used the SH minus nucleophile. And the reaction occurs in the similar fashion as that of the nucleophile of OH minus. SH minus prefers to attack over the carbon, which is carrying the leaving group of iodo, and then iodo leaves out and iodine minus, and you will get the propane thiol. Let's move on to the other alkyl halide system, wherein the CH3CH2Br. The name of this compound?
Ethyl bromide.
Ethyl bromide, right? So
Three bromides.
ethyl bromide. The Cl bond cleaved during the reaction, so that is have been shown here, and along with that you have used CH3OMe. What is that?
Methoxy, sir.
Yeah, methoxide. Right, so methoxide. So as it is carrying a negative charge, the methoxy anion or methoxide. So methoxide acts as a nucleophile in this reaction, and it prefers to attack over the carbon which is carrying the leaving group. The leaving group in this case is
Bromide.
so bromide.
Bromide.
So bromide is the leaving group, and the methoxide tries to attack over the carbon which is carrying the leaving group. Simultaneously, the CCl bond, that is a CBr bond cleavage, and you will get CH3, CH2O, CH3, and along with that, the Br minus. So that is the leaving group leaves out. The CNU bond formation. That means the cleavage of old bond between the carbon and the leaving group, and the new bond has been formed between the carbon and the oxygen. The CNU bond, that is carbon and nucleophile bond formation, and carbon and leaving group, there is a bond breakage. If you're seeing all the substrates, if any of these substrates alkyl group, the CH3Cl, the same, the leaving group leaves out with the heterolytic fashion. And if you're looking into the second example, here also heterolytic fashion, the leaving groups leaves out. And in this case too, the Br leaves out as a Br minus. And simultaneously, the CH3 minus attacks over the carbon which is carrying the leaving group. And you can notice that during the nucleophilic substitution reaction, a new bond formation and the old bond breakage will happen. And the new bond generally occurs between the carbon and the incoming, that is nucleophile. And the bond breakage do happen between the carbon and the leaving group. Is it clear? Any doubts with this general nucleophilic overview, nucleophilic substitution reaction?
No, sir.
Okay. So like nucleophile, you need to have for the any kind of nucleophilic substitution reaction, you need to have a nucleophile and the substrate. Along with that, there should be an existence of leaving group. So the leaving groups generally leaves out, and the new bond formation happens between the carbon and the Nu. And certain examples, okay, fine. Suppose if you have an alkyl halide and reacts with the nucleophile of OH minus, you will get the methanol. Suppose alkyl iodide, then treat with the thiol, SH minus, then you will get thiols corresponding. Then if you have an ethyl bromide, then methoxide ion. Along with that, if you have, then if the reaction between these two will leads to the formation of the product. Which type of product this is?
Ether.
Ether. So ether is the product. Which ether? Name this structure.
Methoxyethane.
Methoxy.
Methoxyethane.
Yes,
Methoxyethane.
methoxy.
Yes, sir.
And this is ethane group. So methoxyethane. Fine. So with this example, you can prepare a various product if you have an alkyl halide. Only by changing the various nucleophilic system, you can prepare the methanol If you want to prepare a thiol, you can prepare thiol by changing the, instead of using the OH minus, you can use the SH minus. And suppose if you want to prepare an ether as an end product, then you need to use methoxide and the respective alkyl bromide. So it is clear that the nucleophilic substitution reaction, with the help of nucleophilic substitution reaction, one can transform the various alkyl halide system into the respective product formation, start from alcohol, thiol, and ether, and many more reactions.